First, I would like to thank the conference organization committee for choosing me as a speaker. So I like to be with you in scientific conference always. I am now speaking to you from my country, Egypt, where I'm an associate prof of architecture and urban design at Azhar University in Cairo. Our topic today is climate improvement, and it's considered one of the most important topics covered at the global level. As my college, Dr. Ghadar Rais, and I worked on a system for cooling the external pavement and uh, published in published it in Sustainable Cities and Society journal, available at Science Direct, 17 October 2020. It took a great effort from us to obtain good results, and it's considered as a starting point for changing the local climate by cooling the external pavement. This title, developing a novel solar driving cool pavement to improve the urban microclimate. Living sustainably means living in a way that can continue beyond our lifetime. A lot of the behavior that has contributed to climate change, such as burning fossil fuels and cutting down trees, is almost sustainable. It's happened because we have only been thinking the needs of our own generation instead of thinking about
Dr.
the
Ahmed,
long-term future
your presentation
and the, excuse me,
is on first slide. Can you change your slides?
okay,
Still, we can see the
excuse
first slide
me.
of your presentation.
Okay. The first, I talked something about my topic. So I will continue. Okay,
Okay,
just an introduction. So,
fine.
instead of thinking about the long-term future and the people who will live on the planet after us, as well as being good for our mental and physical health, buildings, relationship between the nature world makes us more likely to want to protect it. Okay, this is my biography, and this abstract, the thermal properties of pavement play significant roles in raising urban temperature and creating urban heat islands. This phenomenon leads to increased energy consumption in buildings and reduce the thermal comfort of outdoor urban spaces. A standard modest application of thermoelectricity has been limited to indoor use to cool or heat buildings, and outdoor use to harvest energy from asphalt. While the application of thermoelectricity, thermoelectric technology to cool the outdoor environment is rare. A novel solar driven pavement thermoelectric system, SDBTES, has been developed to use solar energy in combination with rainwater or gray water to decrease the outdoor ambient air temperature. and improve the urban microclimate. SDBTES prototype was fabricated to verify the cooling capacity based on outdoor tests in the hot climate of Cairo. The study found that the application of SDBTES led to a reduction in pavement surface temperature of 14.1 degree compared to conventional concrete music pavement. These results represent a starting point for the development and application of thermoelectric paving technology for outdoor cooling purpose. This index introduction, the main idea, cool pavement system, SDBTES components, the durability of the aluminum tiles, developing the cooling technology. The weather change is our new air problem as it affects different sectors as farming, manufacturing, and commercial indirect way, with which leads to the rising cost of every sector. To save business this cost is being cost governments and large institutions, even in real estate sector and medical sectors. As an example, the pharmacological storage and theoretical industrial depends mainly on cooling temperature, which cost high budgets for the large medical corporations to save their products in defended cold temperature or a demoderated one. On other side, if we mention the real estate and infrastructure, we will find that cool systems are budging high costs, which influence the financial budget. So if we put in our considering the Gulf cities, which always is suffering from high temperature. As an example, if we take country like Kuwait, it record from few weeks over 50 degree, which affects even some stuff on the street, which starts to get melts, a car, tires, and light pool. So the weather high temperature become a problem, which will cost the government much to solve to protect the investment and citizens themselves. Quickly, this video, this video for main idea, you can see that change of temperature of pavement tile. This degree is 30 degree, and this 30 also. This under this tile SDES, the system under this, and you can see the degree, degrees. And although the following video, which shows the degree of cooling and its speed in cooling, also compared to the room temperature, which is 30 degrees Celsius. I leave you to watch this and notes that change temperature quickly until it reaches the lowest degrees, which is 19 or less. And from here, we must stop for a scientific event, which is calling to improve the climate, quarter urban areas, and especially in hot countries. You can see 30, 22 now, 21. You can see this degree in this video. Yes, 21.3, this 30, and this 21, and cool, 20, this degree, minus 10 minute, 10 degree. I think in 1 minute, take 1 minute to get this 19. So after finish this video, you can stop in 19 and 30 and 19 degree for cool this pavement. This cool pavement system drawn by authors, components, the solar panel outdoor and battery, this to get the system, and this tile, aluminum tile, 30 and thickness 10 milli. It's raised on pedestals. It's a raised floor. It's a raised floor, and takes the water from rains and drains rainwater, also gray water. This drawings for cool pavement system. SDBTS components, aluminum tiles and solar system or battery or controller and Peltier models and aluminum cooler, everything for cool pavement. Also, this durability of aluminum tiles, this mine for durability, these tiles, and the height of this system 7 centimeters, 7 only. We can put any tiles outdoor for cooling, and this thickness 5 milli. This thickness of tiles 5 milli also. Finally, developing the cooling technology, the future design of the new version dwelling, which needs funding from research centers to produce it for cooling tiles from the author's drawings. Really, these drawings, we make it God willing. Okay, thanks. Any questions? And this is my link of my research on ScienceDirect.